Hello everyone. Today let's solve the problem number 703. Right. So we are done with the this one binary tree. Right. So let's solve some problems on heap or minimum priority queue. So what the question states here. So let's solve the problem number 703 here. Kth largest element in a stream. So you can just go through the question and you can just go through the example. Try to understand the question. I'll just summarize the question so that it will be easier to understand. So what the question states here, we need to design a class kth largest. You can clearly see, or this one kth largest. We need to design kth largest class that maintains a stream of test scores. So that maintains a stream of test scores and efficiently finds the kth highest score after every new score submission. So that's what we need to find here, right? We need to design the kth largest class that maintains a stream of test scores and efficiently finds the kth highest score after every new score submission. So that's what they have given here. And initialization part, this is nothing but the initialization part here, and this is the add operation. So this is add operation and this is the initialization part, and the return value of the initialization will always be null. Just keep this one in mind. Only the return value of the add here they have given number. In this case return value should be number. In this case return value is null, right? So just keep this one in mind. Initialization, we are given an integer k. So we are given an integer k, this one here, sorry, this one. We are given an integer k, which tells us we need to track the kth largest element, right? And also we are given an array nums, here you can clearly see, which represents the initial test scores. So this represents the initial test scores, and k is an integer which tells us we need to track the kth largest element. So I hope this is clear. So the second part is operations, nothing but add operation here, right? Add method, we can say. So here this function takes a new test score val. You can clearly see here. Basically the function takes a new test score val. This adds it to the stream. This adds it to the stream here. You can clearly see. This adds it to the stream and returns the kth largest element from the updated list. It has to return the kth largest element from the updated list here, the add operation. So let's see the same thing while we discuss the example, right? So let's initially go with the approach. Let's see the approach and then let's discuss this example in detail. You'll clearly understand when we discuss this example in detail. Either let's consider the example 1 or let's consider example 2. Let's consider example 1 itself and let's discuss this example in detail. First let's discuss the approach, followed by discussing the example, and then let's write all the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. As usual, initially let's go with the approach. So let's discuss the approach step by step. First thing we have to keep in mind here is we are going with the approach minimum heap or min priority queue, or the minimum priority queue. So here, how do we efficiently track the kth largest element first? So first step is, instead of sorting the entire array every time, so we can just sort the entire array every time, right? And then this one, we can find the solution. Instead of sorting the entire array every time, we can just make use of the minimum heap or the priority queue of size k. So here, instead of sorting entire array every time, we can just go for the min heap of the size k, right? So instead of sorting, we can just go with the min heap of size k, right? This is first thing. So second thing is here, min heap basically it ensures the smallest element is always at the top. So that is the reason we'll be making use of the min heap, right? So min heap always ensures that smallest element is at the top, is at top. So Max heap always ensures that the maximum element is at the top. Min heap, we know that the smallest element, it ensures smallest element is at the top, right? So this is second thing that we need to keep in mind. And in this way, the kth largest element is always at the root of the heap. Now we know that kth largest element is always at the root of the heap, right? Because we are making use of the min heap, and min heap ensures that the smallest element is always at the top. So the kth largest element is always at the root of the heap, right? So let's see how this one basically works, right? Let's see how this works basically. So here we are initializing a min heap. First thing, let's go with the initialization here. Initialize min heap. First thing means we are storing at most k elements in this case. So when I say we are initializing min heap, we are storing at most k elements. This is first step. And what will be the second step? Again, I'm telling, first step is we are initializing min heap. That means we are storing at most k elements. I'll just give here. We are storing at most k elements. So here next step is add operation, right? This is the initialization part. So in the question we have initialization and add operation. Initialization of the min heap here, and here means we are storing at most k elements. Just remember this one for the initialization. Next thing is add operation. Nothing but add elements efficiently, or add elements. Just we can give here add elements. So what does this contain? The first step here is, if the heap contains fewer than k elements, heap consists of fewer than k elements, then just add the new element. In this case, just add new element, right? If heap contains fewer than k elements, then just add the new element in this case, right? This is very important. This one we have to keep in mind. The second step is, if the heap already has k elements, if the heap contains fewer than k elements, then we are just adding the new element, right? If it has if already heap is having k elements, then add the new element and remove the smallest. If it already has k elements, sorry, just give me a second here. So just give me a second here. Already has k elements, then we will just add the new element, and after adding the new element, remove the smallest. Remove the smallest element. Just keep these three things in mind. Whatever I'm saying here, this is for the initialization. So we are initializing min heap just to store at most k elements. This one is initialization, and return value here they have mentioned it is always null. Initialization part, return value will be always null. This one you remember. The second part is adding the elements. When heap contains fewer than k elements, we are adding a new element. First thing. Second step is, when heap already has k elements, we are adding the new element, and we are removing the smallest element, as we are dealing with the min heap, right? So we are removing the smallest, right? So the third step is, the root of the heap now contains the kth largest element. Now the root of the heap contains kth largest element. This is simple, right? Now we saw the initialization part. This initialization part, I hope this is clear. When heap has fewer than k elements, we are adding a new element. This one for the add operation, first step. Second step, if it already has k elements, then we are adding a new element and removing the smallest. This is the second part. And finally, the root of the heap contains the kth largest element. So that is what we have to do. I hope the approach is completely clear here. Now let's discuss the example that they have given in the question step by step, and then finally write the code and discuss the complexities of the code that we have written. Now let's discuss the example that they have given in the question. So let's discuss this example step by step. The whatever example they have given in the question, first example that I have considered here. So same example I have considered here, right? Let's see this one step by step. So here, kth largest add they have given 5 times and the numbers. So this one they have given, output finally they have given. So first step is according to the approach, initialization part, right? So we have to initialize the kth largest with k equals 3 and nums they have given here 4, 5, 8, 2. K equals 3 they have given and numbers 4, 5, 8, 2 they have given, and we are considering this one kth largest here. So let's initialize k equals 3, nums they have given here 4, 5, 6, 8, right? 4, 5, 8, 2. Sorry, this one. Just give me a second here. I'll delete this entire thing. Anyway, this will be step 1. This let's consider k equals 3 and nums let's consider here 4, 5, 8 and 2 here. This is fine. And we have to insert the element one by one. That we know that. So that we know, we have to maintain the heap property, right? So we are inserting the element one by one. First, we create a min heap with a min size of k equals 3 because they have given k equals 3. So let's start the heap operation. So first what we will do, we will, let's consider this one as heap operations. We are going with the heap operations now. So this one, initially what we'll do, we will insert 4. Next step is it will insert 5. This will be now 4 comma 5. Next step is we will insert next element, nothing but 8. Now this will be 4 comma 5 comma 8. Next step is we are inserting 2 to the heap. Now we have 2 comma 4 comma 5 comma 8. Smallest element, from smallest element will go, right, as we are considering the min heap. So here this will be 2, 4, 5, 8 and we are removing the smallest. If it has already size k, if heap contains already size k, here k is 3, it should contain only 3 elements, right? Here in this case it is containing 4 elements. If heap has already 3 elements, I mean k elements, then we are removing the smallest. This we have discussed in the approach. Here in this case smallest element is 2, we are removing the 2, then it will be here 4, 5, 8 now. So final heap after the initialization will be 4, 5, 8. I hope this is clear. Now the third largest element after the initialization is 4, this one, right? So this is at the root of the heap. Now the third largest element after initialization is 4. In this case, we'll be considering 4. Now, the third largest element after initialization is 4, which is present at the root of the heap. That's what we discussed in the approach. So, this is for the step 1. So, next, let's move on to the next step. Nothing but they have given here in the question. This is for the kth largest we have considered 3, 4, 5, 8, 2. Next, let's move on with the add and let's move on with the element 3 here. So what we'll do here, our process is nothing but here step 2, right? So this one we are adding 3, right? Element 3 we have to consider. So first step what we will do, we will insert 3 now. We have 4, 5, 8. We are inserting 3 to 4, 5, 8. Now this becomes 3, 4, 5, 8. So previously we can see here we have 4, 5, 8. Now we are adding 3 here. This becomes 3, 4, 5, 8. And we are removing the smallest element out of this one. Again, we are removing 3. Now this one will be again 4, 5, 8. In this case, the output will still remain as 4 itself. Third largest, right? 4 itself, right? This is at the root of the heap. So the output remains 4. Let's move on with the step 3 now. This one, let's come here. let's see here. We have to consider add of 5 in this case. Let me consider here add of 5. So here this will be, we are adding nothing but we are inserting 5 to the heap here in this case. So now the heap will be the smallest will be 4, 5, 5 and 8. So now heap becomes this one. We have to remove the smallest. This time we are removing 4. The heap final heap will be after inserting 5. This will be 5, 5 and 8. Right. So now the output will be 5 because this one, the first element, this one will be at the root of the heap. Now the output will be 5. Right. This one will be at the root of the heap. Output will be 5, nothing but the third largest element, root of the heap. Answer is 5 for this one. Let's move on with the step 4. Right. So let's see here. Let me come this one. So let me come to the first page. So here we have to consider add and we have to consider 10 in this case. So let me come here, add 10, right? So this will be here, add of 10, same steps, we are inserting 10 here, right? 10 to 5, 5, 8. This becomes 5, 5, 8 and 10. So the smallest element, case 3, right? We have to remove the smallest element now. So we will remove this one 5, right? So now the elements in the heap will be 5, 8, 10. So this is at the root of the heap. This will be the output. Again, the output will be 5, third largest, which is present at the root of the heap. So let's move on with the step 5, right? So this one will be, let's consider here. This one we have considered add of 9 and add of 4, right? Let's keep this one in mind. Add of 9 and add of 4. So here we are inserting add of 9. This will be, we are inserting 9 to the 5, 8, 10. This will be 5, 8, 9 and 10. We are removing the smallest element. Now this will be 8, 9, 10. This is at the root of the heap. This will be the output basically. Output will be 8 and this will be at the root of the heap. Nothing but the third largest element. This will be 8 basically. This is step 5 here. So in this case, let's move on with the final step here. Add of 4, I think, right? So here, this one also we consider. This one, the final one is 4 here. So I'll just come here. This is of step 6 here. This one will be add of 4. So we are just inserting the 4 now. Previously we have 8, 9, 10 in the heap, right? So I'll just give here, in this case, 4, 8, 9 and 10 here. Yeah. So here now we have the heap size greater than 3. We are removing the smallest 4 here. From the heap we are removing the smallest element 4. Now we have 8, 9 and 10 in the heap and this is at the root. So this will be considered as the output. This is at the root of the heap and also the third largest element. So this is considered as the output. 8 will be the output here, right? So these are the steps we have to keep in mind. So the first thing we have got the output here is at the step 1. We have to go with null, right? So just give me a second here. So yeah, here in the first step we have got the output 4, but this is the initialization step, right? So this is initialization and we know that the return value of the initialization, we have discussed this one, will be null. In the question they have given return value, this is null. Only the return value of the add is number, right? So in this case the output we need to consider null for the first step. So for the second step we have got the output this one 4. We return value is number, so we will go with 4. Null and 4 we have now. For the third step we have 5. So the return value, again return value of add is this one, number. Now we have null, 4 and 5. So this again we are having add, the return value is number, we have 5, null 4, 5, 5. Finally this step 5 again add, we have 8, null 4, 5, 5, 8, and finally this one is also add. This one is number of the return value number 8. So the output that we got here is, let me consider one thing here. Let me do one thing here. Output we have is, first one is null, second one is 4, 5, 5, 8 and 8, right? So that's what they have given in the question as well. The output they have considered here as null, 4, 5, 5, 8 and 8. That's what the output that we got, right? So the approach that we went with works absolutely correct, right? Now let's discuss all the edge cases one by one and then finally write the code and discuss the complexities of the code that we have written. For now, let's discuss the edge cases one by one. So the first edge case that we need to consider here is minimum input size. Let me come here. This will be minimum input size. So minimum input size, let me consider here input kth largest of 1, empty array here. This is fine. I hope this is completely clear. So let me give here add of 5. The output will be 5 in this case, right? So because when nums is empty, so we are having nums here empty, right? When nums is empty, we must handle the case where the first add call determines the kth largest element. Add of 5, nothing but this one. We are adding 5, right? This will be the smallest element itself. So now the output will be 5. This is for the condition minimum input size. Let's move on with the second edge case now. Here, when k is larger than initial elements, when k is larger than initial elements, this is fine. And k is larger than initial elements. Let's consider the input here. Kth largest here 3 and 2 within this one. This is fine. So now let me consider add of 3 and add of 4 in this case. So here the output will be, in this case output will be 2 and in this case output will be 3. So why the output here is 2 and 3? Because when k is greater than the length of the nums, we know that here when k is greater than the length of the nums, the function should still return the kth largest element, even when the nums has fewer elements initially. So in this case, output will be 2. This one will consider, and the add of 4 output will be 3. Will be considering, right? So I hope this is completely clear. This is for the second edge case. K is larger than initial elements. So let's go with the third edge case now. Nothing but all elements are equal. So this is for the condition all elements are equal. So let me consider here kth largest of 2, all elements are equal, right? Let me consider 5, 555 here in this case. So if we go with add of 5, then output will be here 5 as well. Why the output here is 5? Because we have all the elements that are same here. So the output obviously remains constant. You can clearly see all the elements here are same. So the output remains constant. So the output will be 5 in this case. So this is for the condition all elements are equal. Let's discuss the final, not the final edge case, sorry. Let's go with the fourth edge case, handling negative numbers. So here, let's go with the edge case, handling negative numbers. So let me consider here kth largest element, right? Kth largest element. Kth largest 2, negative numbers we are considering this time. -10, -5, and let me consider some number, -3 or something. Yeah, this is fine. So let's add -1 here. Add of -1 I'm considering. Now the output has to be -5. This one, second element. So output has to be -5. Why the output is -5 here? Because we are ensuring the solution correctly handles the negative value here because because we are considering the kth largest, this one here. Here the minus 5 will be the this one. According to the k elements, minus 5 will be the output here. So next, let's move on with the fifth edge case, nothing but large input size here. Large input size. For the large input size, let me consider here kth largest. When I say large input, let's consider 10 to the power of 4 and anything. Let me consider here some random value, right? Let's consider some random value over here. So add of some random value. Any value you can consider. Large number, we are considering for the large number, right? So output has to be here. In this case, output has to be kth largest. Previously, we have considered kth largest here, this one of minus 5, right? So here in this case, output will be the kth largest because we are considering here large input size of a random value, any random value, which is of, we are considering for the large input size. So I hope this is clear. These are the 5 edge cases that we need to keep in mind. First one is for the minimum input size. Second one is for the k is larger than initial elements. Third one is for all the elements are equal. Fourth one is for handling the negative numbers. Finally, this is for the large input size. I hope all the edge cases are clear. Next, let's write the code and discuss the complexities of the code that we have written. So let's start writing the code. So one more thing here, we just have to keep in mind here is, so whenever we are asked to design something, it is better to go with the class rather than the function. It's better to go with the low level code as much as possible, right? So whenever we are asked to design something here, we are asked to design a class, this one, I mean kth largest, that maintains a stream of test scores, and efficiently what we need to do, we have to find the kth highest score after every new score submission. That's what we need to do here, right? So we have been asked to design something. So let's go with the low level code as much as possible. I'll just be making use of class instead of the function in this case, right? So this one remains the same, name remains the same, and add, we have to go with the add method and the initialization part. Initialization, let's go with the constructor as we'll make use of the class, and this one will go with the add itself, add method itself within the class. So one thing we have to keep in mind, as I have said this one several times, so initialization, this one, return value of the initialization is null. We have seen that one in the example as well, and the return value here they have given number. So this one we have to keep in mind. So let me completely delete this one and let's start writing the code. So I'll just consider class. So the name was here k largest, right? So first one was the initialization part. So I'll just make use of the constructor. We were having the parameters k and nums, right? So within the initialization in the function. So I'll just consider what we have to initialize here, k, nothing but this dot k equals, let me initialize this one to the k, and we are going with the minimum heap. We know that one, right? We are making use of the minimum heap to maintain k largest elements. So I'll just give here this dot. For min heap, I'll just consider min heads, nothing but min heap here. New min priority queue here in this case. So nothing but the minimum priority queue. I hope this is fine. Next step is we have to insert each number from nums into the heap. This we have already seen in the example as well as the approach we have discussed. We have to insert each number from the nums array into the heap. For that, I'll just make use of the for loop. I'll just give here I equals 0 less than length of the nums, and let's increment the I. So now let's utilize the add function to maintain the heap property. We have not written the add function yet, so we can write this one after, or I'll just give here this dot nums. Just keep this in mind. We are just utilizing the add function to maintain the heap property here. This will be the iterated value of the nums here. So we were having the add method in the function as well, right? So if you remember, so the parameter was value. So we'll go with the same thing, add of val. First, what we are doing, we are inserting the new value into the heap. How can we do that? We have min heap here. This one we are considering, right? Min heap, we are inserting. For inserting, we'll be going with the n cube. As we are dealing with the min priority queue, right? We'll be making use of the queue. For insertion, we'll be making use of the n queue of the value. So we are just inserting new value into the heap in this step. Next, if the heap size exceeds k, then we have to remove the smallest element. We have seen this one in the example as well as while we discussed the approach. So now if the heap size exceeds k, then we have to remove the smallest element. How can we articulate this one in the form of code? I can just write here this one, min heap. This keyword we have to make use of as we are dealing with class, right? So here this one, right? Min heap dot size. If the size exceeds k, so this one size function, if this exceeds k, then we have to remove the smallest element. So to remove, what we'll be making use of? We'll be making use of dq, right? So for adding or the insertion, we'll be making use of n cube. For removing or deleting, we'll be making use of the dq. Now here we have to remove the smallest element. So I'll just give here start. Let me copy this one instead. This one dq, right? So this is fine. So let's move on with the final step here. So the kth largest element is always at the root, right? That's what we have to return now. So we know this one, the kth largest element after removing the small this one, smallest element is always at the root. That's what we have to display in the form of output, right? That's what we saw in the example as well as that's what we discussed in the approach as well. This one, how can we articulate this one in the form of code? We can just give here minimum heap front and rear properties we have, right, in the queue. So we can just make use of the front here, front dot element. So this is nothing but we are returning the kth largest element that is always at the top of and yeah, that is always at the root. For that we'll be making use of the front. So in the queue we have front and rear properties, right? We can just make use of the front, right? So I hope this is clear. So let me format this one once and let me run the code. Kth largest is not defined. Just give me a second. So yeah, here this has to be capital K, I think. This I have given small k. Let me make this one capital K. So this is fine. Let me run the code again. This dot nums is not a function. Here in the line number 7. So this one has to be add property we are making use of here, right? So we are just utilizing add function to maintain the heap property here in this line. So this has to be add, not the nums. So I have given wrong here. So let me hit the run button again. I hope this time this works now. No? What's wrong? No. No, cannot read properties of undefined. This I have mentioned twice here. Let me remove one this. So many typos. So let me hit the run button. I hope at least this works now. Again runtime error. K is not defined. Where? So this dot minimum hit greater than K. So yeah, what mistake I've done here is in the line number 14, this has to, we have to make use of this keyword. So we are going with the class. Yeah, this is fine. Let me hit the run. I hope it works this time. Let's see. Yeah, now you can clearly see the sample test cases are getting passed here. So let me hit the submit button. Some typos here, right? This is fine. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct now. Let's discuss the time complexity and the space complexity of the code that we have written quickly. So what will be the time complexity here? The time complexity of the code here is this one, big O of log k here. This one time complexity will be big O of log k because NQ and DQ operations in the min heap takes big O of log k. We know that one. And the add function also we are making use of here. So we are making use of here DQ and NQ. Here you can clearly see NQ and the DQ operations in min heap takes big O of log k, and add function here, the add function runs in big O of log k, and the constructor takes here this one constructor also we are making use of for the initialization part, right? So the constructor takes big O of n log k. So overall so we are making use of the add function that returns a number, right? So let's take the time complexity of this one NQ and DQ and the add function, this one add value. So this one will be big O of log k here. So what will be the space complexity now? Here the space complexity would be big O of k. Why the space complexity would be big O of k here? Because heap can store up to at most heap can store up to k elements, right? So that is the reason the space complexity here would be big O of k. The time complexity would be big O of log k, and the space complexity would be big O of k in this case. I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.